For thousands of years, humans woke up with the sun, and today we wake up to alarm clocks. But what if I told you that every cell in your body might be screaming against the schedule you're forcing it to live by? That your ancient biology is at war with modern time, and the consequences are written in your DNA. And when you fight your DNA, fatal car accidents spike, teenagers are chronically sleep deprived, and shift workers face dramatically higher chronic disease risk. This is the story of clock time versus biological time, and why understanding your genetic chronotype might be the key to unlocking your best life. And I'm going to show you that being a morning person or a night owl isn't pure choice. It's written in your DNA. Hello, my name's Adrian, and I'm a physician who just likes to explore a number of different topics. And today we're going to continue our series on time. But this time we're delving into how our ability to measure time and thus schedule our day is affecting our biological clocks, and how understanding your own biological clock could well change your life course and disease risk. In this two-part series, we'll first look at a bit of sleep physiology and how it's controlled, and our chronotypes, whether you're a night owl or a morning lark. And in part two, we'll talk about what we can do to try to minimize the sleep difficulties and touch on some other areas of sleep physiology where relevant. So this is obviously not an exhaustive tome on the topic, as it's just meant to be an interesting conversational talk. So let's get going. Deep inside your brain, about the size of a grain of rice, sits one of evolution's most precise instruments, the suprachiasmatic nucleus. Try saying that 10 times in a row. So in shorter form, the SCN. And this is a cluster of about 20,000 neurons, and it's your master biological clock. Now, each of these 20,000 cells contains its own molecular clock in the form of genes called clock genes, period genes, and cryptochrome genes. And these turn other genes on and off in a 24-hour cycle. So they synchronize like a massive orchestra to create one unified timekeeper. But that's just the beginning. Every single cell in your body, in your liver, in your heart, your kidneys, your muscles, your lungs, they all contain these same molecular clocks. So you don't just have one biological clock, you have trillions of them. And the SCN's job isn't to be the only clock, of course. Like I said, it's to be the master conductor, keeping all of these cellular clocks synchronized. And it uses signals from light and dark to convert them to hormonal signals like melatonin and cortisol. Plus, it utilizes your neural pathways to make sure that all of these clocks are playing the same temporal symphony. So this system controls when you feel alert, when your body temperature rises, when your hormones release, when you feel hungry. And for human existence, it was perfectly synchronized with the natural world through the light of sunrise hitting specialized cells in your retina in the back of your eye. Now, crucially, when darkness falls, your SCN sends a signal to your pineal gland to start releasing melatonin, which is your natural sleep hormone. And you can think of melatonin as a starter gun for sleep. It doesn't knock you out like a sleeping pill, but it tells every cell in your body that it's nighttime and time to prepare for sleep. So part of the problem is that we've invented artificial light, especially those of blue light or heavy in the blue light spectrum. If it's sufficiently bright, it can fool your SCN into thinking that it's still daytime. So your pineal gland, it will hold back that melatonin, and your body doesn't get the starter gun signal to go off to sleep. So you might be trying to sleep, but your biology thinks it isn't time. Your circadian rhythm isn't just influenced by light, of course. The variations in those clock genes that I mentioned previously relate to specific chronotypes, and that is that they determine your natural sleep-wake preferences. And studies of identical twins and families show that anywhere between 20 and 50% of your chronotype, i.e. whether you naturally wake up at 6 o'clock in the morning or if you need to sleep in, is fixed at birth by your genes. And another large study also found that those with the most morning genes wake up about 25 minutes earlier than those with the most evening genes. Now that might not sound like much, but at the molecular level, it demonstrates different biological programming. Now, typically we've heard of morning larks and night owls. Well, another further categorization was brought in by Dr. Michael Bruce. He decided that there were actually 4 archetypes, and I find them quite interesting. And also understanding your archetype, whether you're a morning lark, night owl, or one of these characters I'm going to explain, could potentially transform how you decide to live your life. So let's meet these characters. And the first of the archetypes is lions. And they account for about 15 to 20% of the population. They're your extreme early risers, naturally waking around 5:30 to 6 o'clock in the morning. And their peak productivity happens before noon. And they start to feel sleepy again by around 8 or 9 p.m. And if you're a lion, you've probably been told your whole life that you're responsible and disciplined. Then there are bears. And this is the majority of the population, around about 55%. Bears follow something close to a standard work schedule that we all are aware of. And they naturally wake around 7 or 8 a.m. with their peak energy from mid-morning to around mid-afternoon. They may have a dip around 2 to 4 p.m. but then get a second wind and then they're ready for bed by around about 10 or 11 p.m. Now wolves, they account for about 15 to 20% of the population, and they're probably the most misunderstood. Wolves naturally stay up past 11 p.m. and perhaps even later, and they hit their peak productivity around about 5 p.m. And they struggle to wake before 9 a.m. and often don't feel fully alert until late morning. And actually this is what most closely fits my sleeping profile, and it certainly has impacted me living in a so-called lion schedule. And if you're a wolf, society's probably made you feel undisciplined or even lazy your entire life. And the next are dolphins, and these account for about 10% of the population as well. And they're named after this marine mammal because that mammal sleeps with half its brain on and half its brain off. They're light sleepers. And so human dolphins are light sleepers who often struggle with insomnia. They tend to wake frequently during the night and they rarely feel fully rested. And this isn't just personality typing. Researchers found specific variations in those clock genes I mentioned earlier that predict chronotype. And brain imaging studies can demonstrate that different chronotypes had different patterns of neural activity. So a night person's brain at 9 a.m. literally looks different from a morning person's brain at 9 a.m. So we're looking at fundamentally different kinds of wiring. And chronotype distribution across the map also isn't entirely random. Where you live on the map actually matters, and studies have showed that people living on the western edge of a time zone where the sun rises and sets later are more likely to be evening types than those living on the eastern edge, who tend to be more morning types, which would make sense because your body clock is entrained by natural sunrise, not by numbers on a clock. So if the sun comes up at 7:30 in the morning in the west versus 6:30 a.m. in the east, your biology will shift accordingly. And researchers have even found that this mismatch between environment and genetic chronotype can create what's called social jet lag, where your biological time is out of sync with your official clock time just based on where you live. So imagine 2 people, one in Bordeaux, which is west of France, and the other in Strasbourg, in the east of France. And they both live under Central European time, but in Bordeaux, the sun rises about 40 minutes later, and both have to start work at 8 o'clock in the morning, clock time that is. But for the Bordeaux resident, their body clock feels more like it's 7:20 in the morning, and that's social jet lag basically in action. So even with our genetic programming, environment still plays a role. Our circadian rhythm does shift to later in our teenage years and gradually again as we age, but the key point remains that your chronotype is largely influenced genetically, and fighting it comes with some consequences. So your chronotype being controlled by your circadian rhythm is only half the story of when you feel sleepy or alert. And scientists call this the two-process model. You have two separate interacting systems battling for control of your consciousness every single day. There is process C, that's C for circadian, and that's everything we've just been talking about, from your SCN, your clock genes, your genetic chronotype. This system follows roughly a 24-hour cycle, regardless of whether you've slept or not. But then there's process S, S for, let's say, sleep pressure. And this is where adenosine comes in, your brain's kind of tiredness molecule, or toxin, if you like. Because every time your neurons fire throughout the day, they burn energy and they produce adenosine as metabolic waste. So the more your brain works, the more adenosine accumulates and the sleepier you become. And this builds continuously the longer you're awake. So essentially, the longer you're awake, the more sleep pressure you're going to feel. So it's a little bit like an hourglass being flipped over when you sleep. So the hourglass fills with this adenosine chemical, and as you sleep, it drains away to reduce that sleep pressure. And of course, this is quite fascinating that the two systems don't always agree about when you should be asleep. Your circadian rhythm might be saying, stay awake, and your adenosine system is screaming, you need to sleep now. And this creates this kind of complex dance of alertness and fatigue throughout the day. And it might be why, you're wondering why you get that afternoon crash around 2 till 4 p.m. It could be that your circadian rhythm is naturally dipping slightly and you've been accumulating adenosine for 6 to 10 hours. And these systems temporarily are not, they're temporarily aligning to make you feel sleepy. And in some cases, you might suddenly feel exhausted at 9 p.m, but then get a second wind at 11 p.m. And this could be that your adenosine levels are high, but your circadian system is sending strong signals to stay awake. So they're mismatched. And this is essentially how caffeine works as well. It doesn't give you energy. It blocks adenosine receptors, so your brain can't read how tired it actually is. But the adenosine is still there building up in the background, so that when the caffeine is metabolized and removed, you may suddenly feel a powerful sleep pressure as the adenosine in your brain floods back in to occupy those now released receptors. Now you might ask, if chronotypes are genetic, why do they even exist? Why didn't evolution just give everyone the same optimal sleep schedule? The answer is that we probably don't know fully, but we do have hypotheses. And so imagine early human groups where everyone slept at exactly the same time. Who's going to watch for predators? Who would then tend to the fire in the evening? Who would hunt nocturnal prey or gather dawn-blooming plants? So chronotype diversity creates this natural kind of shift pattern of alertness. Lions were naturally vigilant at dawn when many predators might be hunting. Wolves would stay alert during the dangerous nighttime hours as well. Bears would handle the midday activities, and dolphins, with their light sleep, could quickly wake up if anything went wrong. So this wasn't just helpful, it probably was likely a life or death situation for our ancestors. And scientists call this the Sentinel hypothesis, the idea that chronotype diversity evolved as a survival strategy for groups. And with this scenario, someone in the group was likely to be awake and alert 99.8% of the time, with these different chronotypes naturally covering differing periods. So your chronotype isn't a personal quirk, it's perhaps a genetic inheritance from our ancestors whose sleep timing helped keep their tribe alive. Now, chronotypes aren't just about adults, of course, and during adolescence, something dramatic happens, which highlights really just how cruel, essentially, our rigid schedules can be. Because during puberty, the teenage circadian rhythm naturally shifts about 2 hours later or so. And it isn't rebellion, it isn't laziness, it's biology. The same hormonal changes that will trigger physical development will also delay the circadian clock. So a 10-year-old naturally feels sleepy at around 8 or 9 p.m. and a 16-year-old's brain won't start producing melatonin until around 11 p.m. or perhaps even later. They literally struggle to fall asleep earlier. Their biology won't let them. But teenagers, of course, still need adequate amounts of sleep, let's say 9 hours. And if they can't fall asleep until gone 11 or perhaps later, and they still need 9 hours, then they shouldn't really be waking before 8 a.m. Yet most secondary schools will start between 8 or 8:30 in the morning. And that creates this impossible equation to balance, being at school on time versus getting enough sleep. And the results of this kind of biological warfare can be a problem. Many teenagers are chronically sleep deprived, and sleep problems are a major risk factor for teenage mental health issues. Sleep deprivation increases things like depression, anxiety, and risk-taking behaviors. Sleep deprivation also makes it harder to regulate emotions and make good ethical decisions. Academic performances will also suffer dramatically at a time where students are judged on their academic performance. And of course, when you're tired, teenagers do, of course, drive sometimes to school, and that can cause accidents. So there is, of course, some further proof that it's not it's not character, it's more your biology. Some studies looked at delaying school start times, and when school start times were delayed by just, say, 30 to 60 minutes, good things happened. There was improved mental health, there was better grades, reduced lateness, improved test scores. So we're not dealing with lazy teenagers most of the time, perhaps. We seem to be systematically making an entire generation operate against their fundamental biological programming. So your body doesn't suffer chronotype misalignment silently. And I've certainly struggled with being a late riser, having to wake up early, which causes sleep deprivation and, in some cases, headaches, which can be pretty unpleasant. And those have forced me really to modify my work schedule and my lifestyle to combat against it. And when you're living against your natural biological timing, a cascade of health consequences really follow. And if you remember those trillions of cellular clocks I mentioned, when you disrupt your SCN with irregular light or forced schedules or constant time zone changes, you're not just messing with the master clock, you're desynchronizing every cellular clock in your body. So it's like an orchestra without a conductor, every musician reading from a different sheet of music. So your liver thinks it's time to process food, while your brain thinks it's time to sleep, and your heart is operating on one rhythm and then your kidneys are on another. So sleep deprivation has been shown to increase consumption of high-fat sugar foods and increase visceral fat accumulation. And this is the more dangerous type of fat, leading to potentially organ damage, insulin resistance, and metabolic disease like type 2 diabetes. There are also hormonal changes which disrupt your appetite-regulating hormones and also stress hormones like cortisol, which in itself can increase visceral fat deposition. And this is why the health consequences of chronotype misalignment are so widespread and severe. You get higher rates of obesity and diabetes, increased cardiovascular disease and weakened immune systems, higher rates of depression and mood disorders, and increased cancer risk, and of course, shortened lifespans. Now, shift workers who represent extreme chronotype misalignment show really the ultimate consequences here. They face dramatically higher risks of heart disease and stroke and metabolic disorders and certain types of cancers. Their bodies are in constant biological rebellion against artificial schedules. And this isn't just individual suffering, it's a societal problem hiding in plain sight. We've built our entire civilization around a standard schedule that works optimally for, say, early risers. But a large amount of later risers spend their lives fighting their genetics or over-consuming caffeine, struggling with sleep disorders and suffering health consequences. We've normalized living against our own biology. So in conclusion, here's what I'd like you to see for this video. If you've spent your life thinking you're lazy because you can't wake up at 6 o'clock in the morning, or undisciplined because you're still alert at 1 o'clock in the morning, or broken because you don't fit into the 9 to 5 schedule, you may not be any of those things. You might just be a wolf archetype trying to live like a lion, or a dolphin forced into a bear schedule. You're fighting millions of years of evolution written into your very DNA. But the good news is understanding your chronotype is the first step to working with your biology instead of against it. And increasingly, science is showing us exactly how to do that. In part 2 of this series, I'm going to look at how to identify your chronotype and how to optimize your schedule around your genetics, and how to use sleep science to finally work with your body instead of fighting it. I'll also reveal simple changes happening in schools and workplaces that are proving we can build a world that honours biological diversity instead of punishing it. So how do we end this video with a bit of admiration for our own unique biology? How about this? Every morning as the sun rises over Earth, billions of bodies, plants, animals, humans, they quietly shift to that same rhythm of light and dark. Your heartbeat, your hormones, your very need for sleep, they are not random. They are living responses to the Earth turning around the sun. Even your chronotype is an ancient inheritance passed down in your DNA, once vital for human survival. So when you feel your body resisting the alarm clock, that's not weakness. It's nature reminding you you are part of something vast and magnificent. And clock time may run society, but biological time connects you to the Earth and the sun themselves. And that's a perspective worth carrying into tomorrow. So as always, keep that wonder and keep wondering about life.